All right, ladies and gentlemen, today we are looking at our Chapter 9 test review. I will help you on a few of the problems, and then you are going to work on completing the rest in preparation for your test. So I'm going to help you on number 3 and 4 at the top. It says, determine the correlation, sketch a graph to represent the situation, label the X and Y axis. So maybe just start with the labeling first. So your x-axis, again, it's the number of car passengers. So we're going to write number car passengers. And the number of traffic lights on the route. So number of traffic lights. Sorry, it's a little messy. All right, so talking about our correlations, we could read it as the number of car passenger increases, the number of traffic lights increases, decreases, or maybe there's no correlation, or maybe it's a linear correlation. So we're going to put some dots to represent it, and if it is a positive linear or negative linear, maybe you could actually even sketch what your line of best fit might be. But this one here, if you have like one passenger, does that determine the number of traffic lights? No, the route really determines it. Sometimes you get stuck at a lot of traffic lights. Sometimes the roads, no traffic lights. So it'd just be random data because there is no correlation. Right, number 4, the number of pool parties throughout the year. So we're going to say pool parties. And then we would have maybe months, where January would represent 1, December would represent 12. So let's see here, January pool parties. Now this actually can be identified with a correlation. It's not completely random data, where let's say this is the middle of the month here. So this is kind of like June and July and August and September. That's when you're going to definitely have more pool parties. So January might be the origin 00. So 0 pool parties for January. This one, I think it actually might be better if we, even though we set it up that, it might be better if we organize it with the months of the year for your x-axis. I think that'll make a little bit more sense. Let's change this to months. And this would be pool parties. So January, month 1, or yeah, kind of month 1 here would be 0. Where we have here, you have a lot more. But as the year increases to like October, November, December, it goes down. So maybe it's a non-linear where it goes up and then down, kind of curves, if you will. So this would be a non-linear correlation. Because again, it's not a uphill, it's not a downhill, it's an up and down kind of curve like. All right, so 1 and 2, you're going to try and do the exact same thing there. Label it, come up with your sketch, and also your correlation. All right, number 5. This is very similar to what we've already done, so just briefly talking about it. Label your x-axis, y-axis based on what you have there. Determine what you are counting by. Plot your points. Correlation, line of best fit, equation, prediction, and all of that wonderful stuff. So again, this is very similar to what we have already done. So I actually want to focus on number 6 for us, because I know based off of previous data, this is where students struggle. So this one has already been plotted for you. You already have your line of best fit. Now we need to be able to use our understanding of reading graphs to be able to answer some questions. Now, following our directions are key. So let's see. On number 6, the graph shows the number of lawns mowed by a gardener during 1 week and the line of best fit. Look, it's even bold and underlined to use the line of best fit. Now, the thing about this is some students will not use the line, they will use the data points or the equation and so on. Make sure you read the actual instructions. All right, use the line of best fit to determine how many days will it take to mow 25 lawns. So on here, I'm going to go up to 25, and I'm going to go to the right to the line. So I'm actually going to go ahead and circle where I'm looking at. I'm using the line, not the data point, the line. And if I go down, it looks to be about 3 days. Part B, about how many lawns did the gardener mow in 1 day? Now, the key thing about this one, it's not as specific. It doesn't say use the line of best fit. So looking at 1 day, it's not specific enough. So if it said line of best fit, I would probably select the 10. But since it does not say the line of best fit, I'm going to use my data point, which would be about 12. But on part C, it does say use the line of best fit. So the line of best fit will be used to help me determine my answer. So 6 days. Up. Now this is where some students may get it incorrect. They would look at the actual dot. We want to use the line of best fit. So do a little circle on the line of best fit. Now it looks like we're counting by 5, so this would be 40, this would be 45, so a little bit above 45, so maybe 48, 49, somewhere around there. Again, that's kind of an estimation using your line of best fit. So we're going to say about 48 or 49 lawns. But the key thing again is to use the line of best fit compared to like letter B. All right, part D, identify the correlation and describe the situation. Now, correlation, again, can be found from the dots, can be found from the line of best fit. It is obviously positive linear because it's going uphill, kind of like a line. Describe the situation. If you remember describing the situation, we always ask you to start with the x-axis. So we're going to make a simple sentence. As the number of days worked increases, because remember x-axis is always increasing. What happens to the y information, the lawns mowed? As the number of days worked increases, the number of lawns mowed increases as well. Again, always start with your x-axis. Then think about your y-axis. All right, going to help you on one more, and this is actually what we just learned in 9.3, which is your two-way frequency data table. All right, so we're going to go ahead and complete our data table using our sentences, and then we will answer our questions on all of these parts here. So if you remember, our first one is clear or shaded, if you will. You go to a dance and help clean up afterwards by picking up Coke and Sprite soda cans. Some cans were on the floor and some were in the trash can. Irresponsible children. There were 42 soda cans in the trash can and 14 Sprite cans were on the floor. In all, 72 cans were collected and 50 of them were Sprite. Create a two-way frequency and relative frequency table. So let's see here. Our categories are drinks, which we would say Coke and Sprite. And the other one is, if you want to call it like location, which would be trash and floor. All right, let's see. Ooh, 72. In all, 72 cans. Remember, we want to find our grand total, which will help us on the individual totals as well. All right, I'm going to read and fill it in. You follow along. So it says 42 soda cans in the trash can. So 42 soda cans, Coke, Sprite, 42 goes here because they're in the trash. 14 Sprite cans were on the floor. Sprite, floor, 14. 72 were collected, already got that number. 50 of them collected were Sprite. Looks like those are all the numbers that were given to me. So if you can, switch colors or use a pencil and a highlighter. All right, we're going to use our addition subtraction skills to be able to figure it out. So if 42 were on the floor out of 72, can't I do some basic subtraction and say 30? 42, sorry, were on the trash. 30 were on the floor. All right, if I want to, I can go across here or go across there. Now, if there were 30 on the floor, 14 were Sprite, what's this number going to be here for the Coke cans on the floor? That's right, 16. Because 16 plus 14 is 30. Ooh, I can go this way now. 50 subtract 14, or a number plus 14 is 50. What do we got? What do we got? It's got to be a something 6, right? 14 plus 6 is 20, and I need 50, so there we go, 36. All right, working a way across, if you wanted to, you can go there. 42 subtract 36, or 6 plus 36 is 42. Working your way down here, or subtracting, you would get 22. 22 plus 50 is 72. 42 plus 30 is 72. That's my quick check again. All right, my data table is complete. I can go over here and do my two-way relative frequency table. So again, we have Coke, Sprite, total, what is it? Trash, floor, total. And like we did in our notes, the easiest way to start it is with the grand total. 72 divided by 72 is 100%. All right, I got my calculator ready, so we'll just do it quickly together. Excuse me. So 22 out of 72 for Coke trash. We'd say about 31%. And if you want to, you could do your subtraction there. And that would be about 69%. Sorry, let's go ahead and write it as, excuse me, 50 divided by 72, which is going to be about 69%. Because 31 plus 69 is 100. Then as we continue, we can go here if we want to. You can really go to any number what's good for you. So we can go to here, 6 out of 72. That's going to be a really low percent. About 8%. So this one would be 16 out of 72. You can do your calculations, or you can do a subtraction. 31 subtract 8 is about 23%. And we continue over here. 36 divided by 72. Ooh, gives me a 50%. Oh, man. Don't use the trash for the cans. So if that's 69%, this would be about 19%, which is from the 14 divided by 72. And then over here, if you want to, again, you can just add them. 8 plus 50 is 58%. And 23 plus 19 is about 42%. Now that I have all of my numbers and percents, I can go ahead and answer my questions. Let me give you a moment there to copy that down. All right, answering our questions now. Really just look at your data. How many cans of Coke were in the trash can? So you're going to look Coke trash, that would be 6. Cans of Sprite were there. Again, how many total Sprite? That was 50. How many cans of Coke were on the floor? Coke, floor, 16. Once you have your data, questions should be really quick. Were there more cans on the floor or in the trash can? So you're looking at the total. The total trash was 42, total floor was 30, so that would be trash can. What is the relative marginal frequency of Sprite? So that would be that information there. Because again, the word relative means percent. Talking about the total Sprite, 69%. What percent of Coke cans were in the trash? Ooh, right here. Because again, percent. It even just gives you percent. Coke cans in the trash, about 8%. Relative, again, percent. Sprite on the floor. Sprite, floor, 19%. Again, if you have your data tables filled out, really quick. What percent of soda cans is Coke? Coke. Total, 31%. Which soda was least popular at the dance? You can do percent or the other one. Coke is 31, Sprite is 69, so Coke. Of the Coke cans, what percent were in the trash? Now this one here, a little bit different. This one, again, some students have difficulty. So we have 6 Coke cans in the trash, but the trash was the total of 22, not the 72 for the grand total. So for this one, you actually have to do 6 divided by 22, and that's the most difficult part for students. This one's called the conditional relative frequency. So 6 divided by 22, let me use my calculator, would be about 27%. All right, we've gone over a few. Hopefully that will help you. Again, you've got several other problems to help you get ready for the test. Please do the best that you can and be awesome.